Hey, remember you solve this two different ways. As Captain Loophole already tried, one of those cannot be a calculator. You gotta have some work to back it up. But as most of you are already finding out, there's probably only one or two calculators in this room that could do that. It's almost like it was engineered a certain way. Okay, I know we got a grab bag in here of sophomores and juniors. I think we had one or two seniors. Yes, no? For registration, oh, I got rid of it. I'll have to put it back on here again. Um, you know what? Finish the thing. Finish the thing.
Oh, no, I see what I did wrong.
You can still do that. I can't even see that. And I believe there's 3 there, 2 there, but I owed you one from Friday. Cool. All right, that should be more than enough time. As you should have found out, it ain't factorable. And if you want to go calculate your zeros by finding where the parabola intersects the x-axis, it don't. So those 2 ways are actually pretty well reduced down to complete the square and quadratic formula. By complete the square, step 1, variables left, constants right. Subtract 5 to the other side. Step 2, divide everything by a. We got x squared plus 3 halves x is negative 5 halves. Oops. Our veterans are probably hurting not having quick draw in here. And then when I add b squared, or b over 2, the quantity squared, to both sides, y'all don't overcomplicate this. If I have 3 halves over 2, dividing by fractions is easy as pie. Flip the second, multiply. Okay, you just double the denominator. So I'm going to add 3/4 the quantity squared to both sides. So plus 9/16. The wrench that is always missing. Then this can be written as a binomial squared, so it's going to be the quantity x plus always half of b. 3/4 squared is, I need common denominators, times 8 times 8, so I'll have negative 40/16 plus 9/16 is a negative 31/16. Solved by square roots. Square root this guy, square root this guy. Thankfully, that's a perfect square already. X plus 3/4 is plus or minus I root of 31 over 4. Bring it all together. X is negative 3/4 plus or minus root of 31 over 4I. And that is if I separate my real friends from my imaginary friends. If we instead did quadratic formula, x is negative b plus minus b squared minus 4ac squared of that all over 2a. B is 3, a is 2, c is 5. When you do this, you got to look at what parts are kind of separated as to where you can calculate or one shot what things go together. I can do this and this and this separately at the same time because they're all separated by some form of operator or parentheses, or yeah, I mean, one's in radical town, one's on denominator, which implies a set of parentheses. All that stuff is already done for me. So I turn that into negative 3 plus minus square root of negative 31 all over 4 Very simply, I just have to simplify by bringing I out, separate real and imaginary. So, you should get all the way to the end of the rainbow. I'm just going to say 2 points for each method, meaning the work involved in them. So, let's say you, I don't know, you did all the stuff, you got this for complete the square, you came over here and you missed a negative. But you did all the work, you ended up with a positive 3/4 and you weren't sure why, just kind of mind went blank, okay, 1 off. Or you did quadratic formula because you know that's your jam. You came over to do complete the square and you goofed right here. Maybe you added like 9/8 to both sides and then it kind of dominoed after that. Or maybe you did that perfectly, but over here you wrote x plus 3/2. That's another common error. Okay, if you know exactly where the error is and there is only one of them, 1 off. But if you're talking about multiple little things that kind of snowballed, then we're looking at the 2 off. Okay? You can always ask questions on those if you're not sure. Your first quiz is going to be Wednesday, and I I have to stress this for those who have not been in the room before. I'm big about that domino effect. I want to give you credit. So many kids, they get their tests back and they're gonna see, we call it the face palm slap of doom. They'll see that next to one of their problems. That's exactly where I went wrong, and you look at it and you go, oh, I was so close to perfect. There's an awful lot of 29 out of 30s, 28 out of 30s in PreCalc when we get our quizzes, okay? A lot. Y'all know what you're doing. It's just the difference between the A and the A minus, between the A minus and the B, is attention to detail like that. So, the homework. I didn't have anyone ask questions, so I'm assuming we're okay. Yes, no, maybe so. Okay. We left off here, and I think in this class we got a couple of practice rounds with completing the square. That's right, because I had changed one and it ended up factorable instead of butt nasty like I wanted it to be. So, if you got a little bit of room somewhere down at the bottom of this or anywhere in a margin before that, he. If you want to cause true chaos, you be a dice goblin. Okay. No. The dice have spoken. Get them. Uh-huh. I said somewhere with example 6, if you got room in a margin or at the bottom one, the problems we didn't do, just do it there. Complete square. Yep. One more just to be safe. I have no idea how it's going to come out. That's just what the dice told me. God, do I still have that or not? Yes, we do. Shoot. Drive. Game club back. My turn. Master department select. Save. So is that going to be negative 18, 75, 18, 6, 5, 23rds, half that, 10 thirds, 10 thirds, 100 ninths, 100 ninths, and 6, 54, 154 ninths, square root 3, that's just divisible by 9, no it's not, 154, 1 by 4, nope. Well, it's 2 and 77, 2, 7, 11. Not factorable. Not reducible. That's where I got. So then I mental math before lunch, so I might be wrong. That's correct. So step one. After we've reviewed this a little bit, are y'all okay with me just combining steps 1 and 2 a little bit faster? Okay. I'll add 18 over there and divide everything by 3. When you add b over 2 squared to both sides, don't overthink this. What's half of 20 pancakes? 10 pancakes. What's half of $20? $10. Half of 20 thirds is just 10 thirds. Okay. Multiply denominator by 2, reduce also works. So I'm going to, there's 2 ways to actually show this. I can say plus 20 over 3 over 2, the quantity squared, and just let your calculator do the work for you. If you don't like fractioning, let your calculator do it for you. I don't care. But that's 10 thirds squared is plus 100 ninths, which means this needs to be turned into something ninths. So I'll turn that into 54 ninths by 9 by 9. Meaning, I can turn that into x plus 10 thirds, the quantity squared, always half of b, square root of c, is square root of, no, not square root yet, 154 ninths. When you square root, remember when you put the radical there, it has to have a plus or minus. And 154 is a number that not many of us are familiar with. So if I tried to, how do I know if that breaks down? How do I know if I can simplify it or not? Besides just, I happen to have a calculator that has a prime factorization module on there. Okay, can always go old school, get that factor tree in there. I know it's divisible by 2, so that's 75, 76, 77, which is 711. Those are all relatively prime. I don't see a pair of factors. There's no perfect squares that go into it. So square root of 154 can't be simplified. It just is but ugly. It stays that way. You feeling okay with it? You're going to forget it in the next 3 months before we hit conic sections again? Okay. I mean, I know it happens every time, but I got to review it. So I did want to start with a little bit of that before we go to next stage review. Oh, before this, the bouncing ball, ADHD Go Bird. Registration this week. Seniors, bye. Juniors and sophomores. After pre-calc, you got choices. If you are a junior in second semester pre-calc, your options are take only trig next year, take trig and calc, one each semester. I would recommend that if you are going into a STEM field. You know that you are going into, you're going to be a pharmacist, you're going to go into, you're going to go to School of Mines, you're going to go into something related to engineering or architectural drafting. If you are not sure, just ask. But if you know you're heading into a STEM field, go take trig and calc next year while they're free, right? Because you don't want to be paying $400, $600, $800 a credit for something you could have just taken in high school. If you're not headed into a STEM field, this class counts as your fourth math for Regent Scholarship and the advanced honors, diploma, all that kind of stuff. And I'll get a lot of kids, they say, well, I like math, but I'm going to be an elementary teacher. I like math, but I'm going to go get my business administration degree so that I can take over mom and dad's business or something like that. If you know you're not headed into a STEM field, you are certain you're not, y'all, every other degree just requires a generals, college algebra and college stats. That's it. That's all they require. They might require maybe one other type of statistics or analysis, but that's it. So if you know that you're not going into a STEM field, I would actually recommend after this, go take your dual credit college algebra, college stats, and get your easy A's, and now you're done with math, like forever. Because dual credit classes are, what is it, like $40 a credit instead of $400 a credit? They're cheap. But the problem is your GPA. If you want to go into a dual credit class as a junior, you need to be at a 3.75 or higher, or have a 24 plus ACT. Or at least this is what guidance office told me last semester. If you're a senior, you can be at 3.5 or higher to do dual credit. Okay, they want a high GPA to do dual credit classes. It's about the only place that GPA matters. It's that and class rank for scholarships are the only places anyone really cares. So if you're a sophomore, spread the pain. Go talk to their junior friends and they will tell you that junior year is rough. Spread the pain. If you are a sophomore and you know you're going into a STEM field, you have the opportunity to do trig and calc next year as a junior, and then you can do dual credit calc 1 for easy A because ours doesn't count for dual credit, and calc 2. Like you could just hop on the train. That's what I did. I started in calc 3 as a college freshman. So you have that opportunity. if you really, really, really want to. Otherwise, spread the pain out. Take trig junior year, take calc senior year, is my recommendation. Or if you're a sophomore and you're already in second semester pre-calc, odds are your grades are pretty good. You would probably be eligible to do the college algebra, college stats thing, dual credit as a junior, and you could just not math your senior year or ever again because you already have your generals done because you know you're not heading into a STEM field. Okay? I try to go through this with all my classes, and I send this out to teachers. I send it out on a remind because there's a lot of misconceptions about what classes are required for what. And we get some kids who will come into Algebra 2 having never taken geometry, and I don't even know how that's possible. Okay? Um, I would not tell you what classes to take in English. You should not ask an English teacher what classes to take in math, right? Like you go to the content expert. Ask math teachers about math, ask English teachers about English. So registration this week, just making sure everyone knows that. Um, radicals. What is a radical? Maybe we incorrectly have been calling this the square root sign. Okay. Squirms in seat. Okay, this is the radical. A radical looks like Radical. Okay, the radical is this to what exponent makes this number. To what exponent will be right here, I'm going to have some number, it is called the index. And whatever's inside is my radicand. Looks like radicard. What do you call it when Captain Picard goes wild? A radicand is just anything within the radical, and the index tells you what exponent or degree I need to get out of radical jail. So the common one is, say I have square root of 64. It's asking what times itself, if there's ever not an index, I know that it's an implied 2, that's as low as she goes. What times itself makes 64? Versus, this says what cubed, what to the third makes 64. And that's a whole different critter. Okay? If you know your powers like you should coming out of Algebra 2, great. Otherwise, if you ever get stuck, you break it down. 64 is 2 by 32 is 2 by 16 is 2 by 8 is 2 by 4 is 2 by 2. If I write within my radical 1, 2, 3, 4, 5, 6 twos, prime factorization, if I'm stuck on something, well, if it's a square root, I would circle pairs. Think of it like there's a level 2 guard sitting in front of radical jail. You need 2 to get past them. But 1 dies in the process. Or if it was a 3 right there, I would circle triples. It's just how many, because it's 2 to the third, of that factor do I need to get out of radical jail. There are some basic rules with those. You can take, and we talked about this with domain, thou shalt not take even root of negatives. Results in an imaginary number. Do you remember that if I ever have a variable, say it's like x to the 8th coming out of 4th root? Well, what's the 4th root of anything to the 8th? Squared. So it comes out like this. Versus if I had the 4th root of x to the 12th, now what comes out? Okay, x cubed, but let's see who remembers their training. Not plus or minus. Okay. When we put in a radical there, if it's an even radical, then I need to put plus or minus. This radical was already here. I'm just simplifying it. So no plus or minus needed. But because there's a positive and negative option, and because I want the positive option, it's called the principal root. Anything squared is going to be positive. So I know that this is okay. But what happens if I was supposed to get a positive number out? What if x is negative 2? Now this says negative 2, negative 2, negative 2. I just took a negative 8 out, but I wanted the positive option. So we need to absolute value on those. If you don't remember that from Algebra 2, write yourself a little note that whenever I take a even radical of a number and I get variable to the odd power, I need absolute value on it. And that is the only instance when it happens. I can do odd root of negatives all I want. Cube root of negative 8 is negative 2. That's fine. That's why the cube root function had that kind of S curve that went down into negative town, because that's legal. That's why even radicals, I had to restrict the range. It only shows half of a parabola, ballpark. Okay. We're going to see that again in PreCalc, where sometimes we have to restrict the range because otherwise it ain't a function. Okay, those are going to be our periodic or inverse trig functions. So all of that is review. Just tell me that you remember your stuff. Go! I dare you to do it without a calculator. It's on the paper in front of you. What are you squinting at the board for? A, B, and C. Example 1. Okay. It is a cube root, yes. Yeah, it's kind of tiny. Good. Always.
Oh, just kidding. I don't know where I got to. I don't know where you went.
I get it. Said if I ever mental math before lunch, you better check my work. Cadence, would you be okay if I just back this up a little bit? Just a little bit. Right there. Thank you. Same thing. Makes me feel weird. Just a little bit. Yeah, that's what happens when kids sit on them. The hex bolts in them get wiggled out of place. Okay. Those of you coming out of my Algebra 2, you have heard this all year long, and I'm going to keep going in PreCalc. You should know your perfect squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as you can possibly memorize. Do you know off the top of your head what is 7 cubed? 7 cubed. Ouch. Okay. 343. You should know off the top of your head what's 17 squared.
But where do you want?
289. And if you don't know those, the way to get your cheater chart on your calculator, you head over to y equals. I'm going to ignore y1 because I'm not taking anything to the first power. This is just my personal preference. Under y2, I put x squared. Under y3, I put x to the third. Y4, I put x to the fourth, and so on. Because now when I go to that table, starting at 0 by integer intervals, it's going to give me my powers, right? Because it's x squared, x cubed, x to the fourth. It's giving you all of your perfect squares. It's giving you all of your cubes. It's giving you all of your fourths. It's giving you all your fifths and so on. Okay? Y'all remember when you first went into Algebra 1 and you started factoring quadratics? Maybe. Okay? Maybe that summer Alzheimer's extended over a few years and we just, y'all, I don't know what I had for breakfast. That was like 2 hours ago. If you recall, maybe, when you first did factoring quadratics, or maybe even just in Algebra 2, if you knew your multiplication facts, wasn't that fairly simple? But then you watch some of your classmates struggle, and they had to keep guessing and checking on a calculator, or they had to break out a multiplication chart. Okay? There's nothing wrong with it. Okay? Use your resources. I want you to. If you are fluent and familiar with the number facts, it makes the rest of the math go faster. You don't have to memorize these. I'm just telling you your life's going to be a lot quicker and easier if you do. Okay? Squares through 20, cubes through 10, fourths through 5. We don't see them past that too often. And as many powers of 2 and 3 as you can get familiar with, because they're just going to keep happening throughout math. They really, really like to use those numbers. Okay? The reason I say that is because every one of the numbers up here should look familiar. Square root of 49 is 7. I'm allowed to have a negative outside. That's what makes my principal root negative, because I have a negative there. Think of it like in the debate context, precedent. They set the precedent, you keep with it. Okay, cube root. I'm looking for what to the third makes 64, not what squared. What to the third makes 27. Okay, and I don't need plus or minus, again, because I didn't put a radical there. Additionally, this is an odd root. Now, if I were to do the fourth root of, that's kind of like the square root of the square root of. Like they kind of stack together. We're going to talk about rational exponents in a minute. Well, I know the square root of this is 11i, but we have not done the proof for, and I don't know, maybe your Algebra 2 teacher did. I keep it out of mine. The proof for square root of I. Like it is an actual value. It's a complex number. Because I know that that's something that Mr. Spear does cover in calculus. We don't know how to do that. Also, just say even root of negative. It breaks the second commandment in domain. Don't do any of this. Just say no. Or not no solution. Say non-real. Okay? I can't do that because it's not going to give me a real number. So, whoa. Okay, we just talked about the whole variable thing. Well, if I have the sixth root of n to the 18th, I have two options. Option one, there's 18 n's there. Mm. And you circle groups of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 of them rush the guard. He's a beefy boy. Only one gets out alive. 6 of them rush the guard. One gets out alive. 6 of them rush the guard. One gets out alive. This is real handy when you get stuck. Sometimes you get stuck and you have to do something you don't want to. If I get stuck moving snow, my truck slides on down into the ditch, I might have to get out and shovel. I don't want to, I'm gonna, because I'm stuck. This helps you get unstuck. Boy, would I much rather just say 18 divided by 6, right? If you know the tricks, you don't have to do it the hard way. Do I need absolute value on it, though? There was an even root and an odd power came out. I need absolute value. I hope you remember that from Algebra 2, but shortly after that, in most textbooks, it'll say, just assume positive variables. That way you don't have to do this all the time. I'm bringing it up because, again, a whole lot of you might be taking ACT soon. I want to make sure that I hit these little gotcha points, these little nitpicky things. If I do the square root of 63y cubed, again, you can do that the hard way, which is prime factorization of a thing. That's 3 by 3 by 7 by y by y by y. Circle pairs because it's a square root. 3 gets out. Circle pair, y gets out. Have a 3y on the outside. These guys, they don't have a friend to rush the guard. They just stare at each other awkwardly and like, screw you, dude. Yeah, screw you. So they're just going to stay in jail. They don't have a buddy. So they stay in jail like so. Do I need absolute value or not? 1 is odd. Odd power came out of an even radical. Do I put the absolute value around the whole works? What needs the absolute value? Just the y. Okay. Now, I usually get someone, the rules lawyer of the classroom, will ask, can I just put absolute value on it every time? Can I just do that? Because then I'm always right. I don't do that for the same reason that I don't write 1x to the first over 1. It's not simplified. Okay? B and D. Go. Take out what you can. What comes out of Radical Town? Remember, only factors come out of Radical Town. Addends do not. Factors come out of Radical Town. The index tells you how many you need.
Why do they have to use peas and the peas on the side? Goodness.
Yeah, about the only thing that would make that P and Q problem worse is if your exponents were 9 and 6. Yeah. And then our dyslexic students just table flip. Okay. I'm sure most of us got, if I just divide this by 5, p squared comes out. This q to the 7th, it's usually better to break up into q to the 5th by q squared. Instead of writing out all 7 of them and just circling a group of 5, I can break it up like this. Because the 5th root of something to the 5th is something to the 1st. Okay, so if you ever want to break it up like that, that's cool. I'm still going to have a q squared inside, and they ask, where's the negative? Treat that negative out front like a -1. What's the 5th root of -1? What times itself, times itself, times itself, times itself makes -1? It was -1. Bring the negative outside. Whenever you have an odd root of a negative, it's always negative. Part B. Remember, factors come out. So the 4th root of 81 is just 3. The 4th root of anything to the 12th, even if it's all parentheses, you just divide 12 by 4, and you get that thing to the 3rd. Okay. And because it was an even root and an odd power, I need absolute value. When someone asks, well, but it's a +1. I don't know if that's odd or even. What if that was an odd number already? Then odd plus 1 is even. I don't need it. Or wait, what if it was like a -1 plus 1 and now it's 0? It doesn't matter. I don't know what it is. So I need the absolute value on the variable part of my expression, or else I might end up saying something that was incorrect. Okay? Because I know what 3 is. It's a +3. That's why, just like back here, it only went on the y. That's the thing I don't know if it's positive or negative. It says 3. It doesn't say -3. Right? The idea is to get a positive thing out of radical land. 3 is just 3. It's a +3. It's not an unknown. Only unknowns get absolute value because I'm making sure. All right. How you feel about that? Sounds like we might need more. Yeah, I'm good. I got that. Easy peasy. Yeah, a little sketchy. Man, I wish I could go back to Friday. Okay. Those 3. We only had 2 ring the bell this time. The Navy SEALs training course, if they ever want to opt out of it, they have to ring the bell of shame because they want out of the training program. We had 2. It always happens first week of PreCalc. We had 2 who said, nah, I'm out. But they were both from the 3rd period class that was already small, so that group's down to 8 now. So PreCalc was really, really close to being able to go 2 sections this year. But I'm okay with it. Small classes are good. Kids usually learn better in small classes. More individual attention, they can ask questions. And remember, with these, ask questions. Okay? If you're not sure, ask. I'll toss that one in there. I'll toss that one in there. What do we think? I know it doesn't go that high. Who said that it's a perfect cube? Like 27 is a perfect cube because 3 cube makes 27. Not just these three, I also put a challenge up there. Let's see if we got it. You remember the prime factorization button on there, right? I wish that was standard on TI-84. It is such a handy feature. Actually, I'd play around with the 84 apps. That's got to be one of the downloadable ones. If we don't know, if we're stuck, prime factor tree, figure out what comes out of it. Well, it's an even number, right?
So 2 and 1,000.
Yeah, just start there. Divide it by 2. Just use a calculator. It's an even number. Try that. When it's no longer divisible by 2, try 3. Then try 5. Then try 7. You go through your prime list. Oh, that was supposed to be 2058. Yeah, I have no idea what it's going to do now. I meant to do it 2058 so that it would be 6 times 343. I missed my 40. Oops. Now I have no idea what it's going to do. Let's find out. For all I know, it might just have to stay in the radical like that. Y'all, there's nothing wrong with not knowing. Especially when you get kids into pre-calc. It's usually the kids who are used to, I've always had straight A's, I have this unhealthy expectation of perfection. My parents get mad at me if they see a minus next to the A. Y'all, that ain't healthy. It's okay to be wrong. I got a whole board to prove it. Okay? People make mistakes. It's okay. We learn through failure. The first caveman to chase the little critter with a white stripe on his back into a hole was like, man, I'm never going to do that again. Because it turns out it wasn't as tasty as he thought it was. Yes, it's a skunk. Okay? Or how about if have you ever stepped on a stink bug? Like a beetle that when you crush them, oh God, it smells about as rancid as a skunk. After that, you're probably not stepping on beetles if you see them anymore. Because then that's stuck on the bottom of your shoe for the next 2 days. Okay? We make mistakes and we learn. Y'all are teenagers, you know this. Your life is defined by I learned it the hard way. Square root of 5 is 5. Cube root of 343 is 7. Fourth root of 16 is 2. When I go over to the variable exponents. Square root means cut it in half. Cube root means divide them by 3. Fourth root means divide them by 4. And then, which, if any of these, need absolute value? Even root, odd power. Odd root, don't care, because they're allowed to be negative. Even root, even power is cool, right? Because if I take a negative to the fourth, negative times negative times negative times negative, it's still positive. So this guy's okay. That guy needs the absolute value. Now this one, again, I intended it for it to be 2058, but I did mental math before lunch and it didn't work out. I know it's divisible by 2 because it's an even number. So I'll divide it and I get 1009 by 2. Nothing?
I don't think so. I haven't remembered anything, but I've also seen.
Like, is 1009 legit prime?
Yep.
You got the prime? Okay. Well, then I guess it just stays in there. But what can I take out? Cube root of a -1 is -1. Break these up into x to the 18th by x squared, y to the 15th by y. You see why I'm breaking them up like that? Because I want something divisible by 3. This skill is an awful lot like what we did with our eyes, that ring, where we wanted to break things up and have them divisible by 4, our exponents. Very similar skill. I get an x to the 6th come out. I get a y to the 5th come out. I'll have an x squared and a y left inside. Well, a 2018 with it. But okay, so towards the back half of Algebra 2, you did radicals like that. Do you remember rational exponents? Okay, rational exponent says that if I have a radical, it can be written as an exponent. That is a fraction. Okay, if you need to see it in its color-coded glory, perhaps we would say x to this thing is root of, x to this thing is root of x to this thing. Where if I have the numerator of an exponent can either be the exponent of a radicand or the exponent of an entire radical, and the denominator of an exponent can be written as an index for any radical. Okay, all three of these statements are equal. The one that's maybe not stressed enough in Algebra 2, most kids see this, because this goes all the way back to Algebra 1. But remember, because of the way that exponents work, I can write this guy, I can write this as there we go. B, B, A. Because whenever I take A times 1 over B or 1 over B times A, basic fraction math, I end up with A over B. So since this can be written both ways, that tells me I can write it both ways as a radical as well. Okay, so both work. And that's what allows me to start simplifying things that I otherwise would not have been able to. Like, if I said the 10th root of 32 and the 6th root of 2 I can't do diddly with that because they don't have the same radicand, they don't have the same exponent. Until I rewrite this as 32 to the 10th, or sorry, 1/10, and 2 to the 1/6. You're like, well, that still didn't do anything. Unless you know your powers of 2. 32 is 2 to the what? 5. So if this is 2 to the 5th to the 1/10th, then that's 2 to the 1/2. Oh, not 16. 1/6. There we go. And what do I do with any exponents when I divide and they have the same base? Subtract. 1/2 minus 1/6, or common denominators, 3/6 minus 1/6 is 2 to the 2/6, which is 2 to the 1/3, which is cube root of 2 to the 1st. Now, do I have to go through that entire chain? No, you can skip a couple steps in there. Skip a couple steps. Yes, words are hard. Okay, B is just the same business we were doing before. If I rewrote this in exponential form, that'd be x to the 21/4, y to the 15/4, which I could call x to the 20/4 by x to the 1/4, y to the 12/4, y to the 1/3/4. And since this is just x to the 5th, and this is just y to the 3rd, they would come out of radical town. These share a denominator, so they can go back into radical town as x to the 1st, y to the 3rd. But why would I go through all that if I could have just done what we got done doing and take out groups of 4? Okay, they're just showing you there's a different way to do it. And whoop, whoop. Don't forget your absolute. Now you group them. Don't forget your absolute value. Once you get the definition of a rational exponent, you're able to kind of ping pong back and forth between different methods to simplify stuff that you probably couldn't have before. Like this guy, if I say 16 to the 3/4 and 16 to the 1/4, boy, are there a bunch of ways to write that. I could say, well, this is the 4th root of 16 to the 3rd over the 4th root of 16 to the 1st. And then rationalize, I need 4th root of 16 to the 3rd, 4th root of 16 to the 3rd. Now this is just 16. Now I have too many of them. That's 16 to the 6. I'll bring 1/16 out and have a 16 squared left inside. And then I'd simplify that part. 2 and 1. Well, then 16/16 is 1. So it's just the square root of 16.
I'm confused. How did we go from 1/3 to
Right?
3/4 on the bottom? I don't like this.
Because I need 4 to get out of radical town, I need 3 more, so that I would have 4 16s in radical town to get out of. It's rationalizing my radical expressions. Okay? This is overkill and a half. No, I'm showing you there's a different way to do it. Because sometimes you run across a problem where that's exactly what you have to do. Or maybe that's the route that makes more sense to you. Dear God, they have the same base. Why would I go through all that effort when I can just say 3/4 minus 1/4 is 2/4? is 1/2 is square root. Well, wait a second. Square root of 16. 4. Okay. So the idea behind this is that you have learned both how to work with radical expressions and how to work with exponential expressions. All of those properties, all of those laws, like you are now the mathematician carrying around the giant bag full of tools. You use what you need to. You choose how you're going to handle that. And because multiplication is commutative and this is repeated multiplication, you get your choice of how to handle it. Whatever makes sense to you. If you want to break everything down by definition, go for it. If you want to turn them into rational expression or rational exponents, go for it. When in doubt, just try something. Okay? I see a ninth root of 5. I'm going to call it 5 to the 1/9 and see if I can work with that. Every one of these can be simplified down to a single term. That term might be ugly. It might have radical with it. But that's okay. That's right. I was going to do the holy sheets. I would recommend for every one of these, the first thing I would do is write them as fraction mode. Write your radicals as a rational exponent. Start there. And then if you know your properties exponents, you should start seeing something you can do. What's that? 6. It's 216. 1296. 72. 72. 100 to 540 is 75. 40. 75, 76. 75, 76.
Looks like a pickle.
Okay. I'm betting contestants 1 and 2 are no problem. Okay, these both got a little invisible 1 right there. So 6 to the 1/4 and 1/3 respectively. To add them, you need, need to multiply by 3 and 3, need to multiply by 4 and 4. So I'll have 3/12 plus 4/12 is 7/12 as an exponent. When I write that, I can write it like this, or what is 6 to the 7th? Is big. I lost it after the 5th. 279,000 mutter 6? 1,936. Okay. There's no hard and fast rule for when I write that number out and when I leave it as an exponent. There literally is no rule that says when you do that. Generally, if it's on my list of crap I should know, like squares through 20, cubes through 10, fours through 5, as many powers 2 and 3 as I can memorize. If it's on that list, I'll write it out. If it's not, I'll leave it as exponent, and that's okay. So both of those are correct. 15, if I write both as rational exponents, simplify 2/10 down to 1/5, well, 2/5 minus 1/5 is pretty easy. X to the 1/5, which is just 5th root of x. 16, as soon as I wrote yellow part, then did we see what was going on? Okay, sometimes you have to simplify before you can combine. Sometimes you combine before you simplify. Multiplication's commutative, both are cool. If I write those out by either prime factorization or I know the largest perfect square, cube, or whatever power goes into a thing. There are just 2 different ways to write it. I could have written this as 3 to the 3rd. I could have written this as 4. Just showing both. If I do that, then it turns out I can simplify each. If I simplify each, I get 2 root of 5 and 3 cube root of 5. Well, now that's 2 times 5 to the 1/2, 3 times 5 to the 1/3. You see how I was able to isolate the thing that had a rational exponent. Because the 2 and the 3 come out of radical town, and multiplication is commutative, I could now write that as 2 times 3 times 5 to the 1/2, 5 to the 1/3. What's outside of radical land stays out of radical land. 2 times 3 is 6. What's inside of radical land stays in radical land. Just make sure that you get common denominators. 3/6 and 2/6 is 5 to the 5/6. And because we're now kind of going in inverse order here, there we go. There. Okay, break up what's inside a radical town, simplify what you can. Rewrite with rational exponents. Rational exponents can go together. I now have 6 on the outside, 6th root of 5 to the 5th, and if you happen to know what that is off the top of your head, go ahead and write it. If you know what that is, go for it. I don't know. My general rule is if it's on that list and it's somewhere under 10,000, like it only goes to 4 digits, no, okay, I'll write it. I'm betting that last one is what tripped us up. So if you got a margin, because I'm pretty sure that's the end of it, right? Yeah. So if you got a margin somewhere over here, I don't care. Let's do, let's try that. 81 times. Yeah, let's do that. Okay, so simplify each radical first. Then what's still in radical land, you can write as rational exponent. Then see what you can combine.
So then 3 can come.
Mm-hmm. Okay, check it with your neighbors. Ask me as I'm wandering around. If you're not sure, guess and check on a calculator. Break out that factor tree. Okay. If I know my perfect fourths high enough, my powers of 3 high enough, I should recognize 81 as 3 to the fourth. I should at the very least recognize square root of 121. I can write it out like this, or you can write it out long chain as prime factors. That's also cool. I could have written this as 3 to the 4th times 3. I could have written this as 11 squared times 3. Whatever you're doing, okay? They're just options. And say the 4th root of 81 is 3. The square root of 121 is 11. Then, what's outside of radical land stays out of radical land. What's inside of radical land, now I can write as rational exponents. Call this 2/4. I now have 33 times 3 to the 3/4, which can be written as 33 4th root of 3 to the 3rd. I better know that one. Okay. Um, this is a type of problem they like to show us on ACT, because this assesses you understand exponents, you understand radicals, you understand fractions. It's a 3-for-1. They love this kind of problem. Okay. Now, we do only have a few minutes left, but that means we got enough time to do the basic stuff of systems. Okay, we'll get into the meat and potatoes of it, the algebra 2 stuff tomorrow. But please tell me y'all remember how to graph a line. I say that with cautious optimism because I did have kids in algebra 2 who could not plot points. I don't know how they got through algebra 1. Graph those 2 lines. Poor favor. Graph the lines. You okay? Graph the lines. Because in here we're going to get nonlinear systems. What happens when I say solve between this cubic and quadratic? Okay, that calculator ain't going to bail you out of everything. It does an awful lot for $18, but it ain't going to get you out of all of it. Okay, if you haven't caught on in the first 4 classes, Levi's got probably my favorite calculator in existence, TI-36X Pro. I got a picture of it on our class page down at the bottom. That thing will practically do your taxes and connect you to the matrix. Like, it for $18, holy crap, will that do an awful lot. Those $10 Casios will too. Okay. I honestly believe they are superior to the TI-84s for 90% of high school applications. And when money is a factor in what we're able to have in a classroom or what you're able to personally bring with you to college or ACT, I recommend them big time. I badgered the manager at Walmart for years and years and years, and after about 5-6 years, they finally started carrying them. I don't know if they have them on stock right now, but they did start carrying them. Please tell me you remember. Now, I bet the majority of you got y by itself and did mx plus b, right? Slope-intercept form. You don't have to. Do you remember graphing by intercept? If I shove a 0 in for y, I get 3x equals -6. X-intercept will be -2. If I shove a 0 in for x, I get -2y equals -6. Y-intercept will be +3. Did you or did you not get y equals 2x plus 4 as your slope-intercept form. The first one. Yeah?
I got 3 halves x plus 3.
Oh, I put that up at 4 instead of at 3. Sorry. It was correct for what I drew. Yeah, that's a brownie point. I missed it. Okay. There we go. 3 halves x plus 3. Sorry. Likewise, this, if I just put in a 0 for x and y, I'm going to see in both cases that I've got an x and y intercept of -2. X-intercept -2, y-intercept -2. Make some more points, connect the dots, use a straight edge if possible. And now we get to the idea of what systems are. A system of equations, hey, I said green. You rap. Okay. What is blue line? Like, what is it? Yes, it is. What is just the blue line? That blue graphed line. It's the graph of the equation what? Okay. We're forgetting our training from Algebra 1, Algebra half. It's the solutions. Everything on the blue line is going to make this equation true. Everything on the red line makes this equation true. So what is green dot? Where they're both true. The intersection is where they are both going to be true. Y'all, it's this simple. Blue line, my wife wants Mexican food. Red line, I hate Mexican food. Green dot, Guadalajara's. They got Mexican food and they got the gringo menu on the back. I can get a chicken sandwich and fries. We're both happy. Okay? That's what a system solution is. It's where every equation is happy, where they're all true. And as you remember, there's a bunch of ways to solve them. Okay? You come in tomorrow, we'll do those and 3 variable systems. If you don't remember 3 variable systems from Algebra 2, get ready.